Welcome to Megasquirt Training Part 4. In this video, we're going to be taking a look at our sensor calibrations. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and talk about our sensor calibration that we're going to be doing with our Tuner Studio software. So what we're going to be finding is when we begin our tuning process, we need to make sure that our basic sensor data is going to be reading correctly. That's going to be things such as our air temp, engine coolant temp, map sensor, throttle position sensor, and our wideband. These are the most basic sensors, and if they're incorrectly calibrated, we're going to be finding that as we do our tuning process, the entire fuel or ignition timing might be all thrown off. And once we fix them, we're gonna have to go back in and go and correct all of our fuel and ignition timing tables. So it's gonna create a massive waste of time. We wanna make sure at the most basic level that everything our Megasquirt is seeing is correct. So in this video, I'm gonna be showing you how to do that calibration process. It's relatively straightforward, and you're gonna be knowing what to do for your own vehicle. So without further wait, let's jump into the video so we can check this out. Okay, so let's get started here. We're gonna be taking a look at how to do our basic sensor calibration in our Megasquirt software. This is going to be the first step that you always have to do when you ever have a fresh installation. We need to make sure that the Megasquirt understands the sensor inputs that are coming in. So it's going to be our throttle position sensor, our map sensor, our intake air temp sensor, our coolant temp sensor, and our wideband. These are going to be always the things that we have to calibrate. Now, if you're using a plug-and-play box from DIY AutoTune and you're running one of their base maps in the configuration, if you haven't changed any of the sensor types from their base map, what they specify, then you most likely don't have to do any calibration other than maybe your throttle position. But if you're changing something, let's say you have a plug-and-play Mazda Miata box and you change your intake air temp sensor to a GM intake air temp sensor, you're going to have to do this calibration process. So we have to keep this in mind, and it's something that I always suggest that you go ahead and do, again, on a fresh installation. So in my case, we're going to be seeing here I have throttle position. We can see right now I'm off the throttle. It's showing here that I am at 9% throttle, and this is incorrect. It's not defining my 0% throttle to my voltage input right now, and I have to go ahead and define this. This is always the first step here. I always go to my throttle position first. If I jump under Tools here at the top and move down our tree, we can see we have this Calibrate TPS. When we click this, we're going to open this calibration screen up. Now what we can see here, we have a closed throttle and a full throttle. And when we have a throttle position sensor, we're going to be finding that's a linear scale. So let's say closed throttle or off the throttle, we have something like a half a volt. And then at full throttle, we might have something like 4.5 volts. We're going to have a linear scale in between that. Every change in voltage is going to be a linear change in our throttle position. It's actually a very simple circuit. So what we're going to be finding here is we have to do our calibration at closed throttle and then a calibration at full throttle. And then we're going to be able to get the min and max positions so that it reports here when we're at 0% throttle, 0% throttle comes in and displays in our gauge, and the Megasquirt's going to be knowing that we're off the throttle. And then when we're at full throttle, it's going to show 100% throttle, and the Megasquirt will know that as well. So the first thing we need to do, we need to make sure we're off the throttle all the way. We do not want to have our foot on the throttle. We don't have anything touching or hanging up the throttle body, so that when we are completely off the throttle plate is shut. We're going to go to this closed throttle ADC count, and we're going to click Get Current. We can see when we do that, it updates the value here, and that's going to be changing these ADC counts that it corresponds for voltage to throttle position, that it records it correctly in the software. Now we're going to be doing the same thing here at full throttle. I'm going to go and bring my throttle all the way up to my full throttle condition. Now we can see I'm all the way to the floor, but my throttle position is reading 85.5%. This is incorrect. We need to update it for the new full throttle voltage position in my particular configuration here. So just like we found with 0% throttle, we need to be all the way off the throttle, or I'm sorry, all the way on the throttle. In this case, doing our full throttle calibration, we're going to click Get Current here, and we're going to be seeing that that number changes. Now, we're not going to see that this is going to automatically report that as showing 100% now because we haven't clicked this Accept button. Now, if we click Accept here, we're going to be seeing that it shows Need Burn. That means that we need to update our controller with this change. Now what I have seen is, in order to make this take, you can go under Tools here, go under Calibrate TPS. I have seen the need to go back in here and click Accept twice, and we can see once we've done that, it now shows 100%. It's just something I've seen in the software. You may or may not experience this, but I wanted to give you a heads up if you notice that it doesn't, after you click that Accept button, if it doesn't go ahead and update your throttle position. So we can see now when I go in here and I lift off my throttle, it's showing me approximately 0. And then when I go full throttle here, we can see that we are approximately 100%. And I'm overshooting and undershooting slightly because I am simulating this input. I'm not actually hitting it dead on because again, I'm simulating this voltage into my Megasquirt controller to display here. So what you'll see is 0% and then 100% when you sweep your throttle. And that's going to be something you always want to test for every vehicle, regardless if it's on Megasquirt or not. It's going to be one of the most basic things. We need to make sure our throttle position is calibrated. So next, we're going to be finding we have our coolant temp sensor. And in this case, for my Megasquirt application, I chose to use a GM coolant and air temperature sensors because these are going to be very easy to source. They're extremely inexpensive. They're very accessible, and they're probably the most universal style coolant air temp sensors that you can get on the market. So typically speaking, if you're going to be doing a custom installation, you're going to be using one of these sensors in your install. And typically a GM intake air temp is the most used when you do a speed density conversion, if you're converting your car over, again, to speed density and taking it off of a mass airflow sensor. So we're going to be finding here, coolant temp gauge here is displayed. If I right click here and I go into my sensor inputs, I can go and select this manifold air temperature, or MAT, and this is going to display what my air temperature is reading. So we can see my coolant temperature showing 178 Fahrenheit. My manifold air temperature here is showing 52 degrees Fahrenheit. Now, I am in a controlled room and my air temp sensors should be reading approximately ambient conditions. So in this case, it's between 65 to 70 degrees in this heat controlled room, and I should see my sensors reflect that. So I haven't started my engine yet, and I'm going in and doing this calibration. Now on a warm engine, you're not going to be able to as easily figure out what that should be at or if it's accurate. I always suggest that when you do your calibrations, that you do this on a cold engine, and you should note the ambient temperature in the condition you're in. So if you're in a garage that doesn't have heat and it's 20 degrees, well then you need to reference that for your temperature reference. If you're in a heated garage, you just want to note what that temperature is going to be, again, on a cold engine. So in order to go in and change the values here, we're going to have to jump back into Tools, and now we're going to have to go down to this Unlock Calibrations. So we can see Calibrate Thermistor Tables, that's going to be our coolant and air temp sensor. They're going to be grayed out. Calibrate AFR Table, this is also going to be grayed out. So we're not able to access the air temp or coolant temp calibration tables until we go and unlock them. Now, they've chosen to go and unlock these values because these sensors really shouldn't have to be edited, or the calibration shouldn't have to be edited as you're doing your tuning process. You know they're going to be pretty much fixed during the entire process, so they have this option here. So if we click on this, we're going to be seeing Unlock Lock. We can see sensor calibrations are in the locked status right now. I'm going to be going selecting Unlock, and then we can see this burn button. I have to burn the change to my ECU to accept that. We can see once we have to burn, the need burn down here goes away because we've updated and we've saved the changes to our controller. So now we're in this unlock state. If we close this out, jump back into Tools, and go down into Calibrate Thermistor Tables. If we click this, we're going to be finding we have this window pop up. Now, what we're going to be seeing here, we have this sensor table. We have a selection. We can either select our coolant or air temp sensor depending on what we want to calibrate. So in this case, I need to calibrate my coolant temp sensor, and it should be reading approximately ambient conditions. So what I'm going to do here is go into my common sensor values, and we can see I'm able to select all kinds of different values here. They're predefined calibration curves. I have a GM coolant temp sensor, so I'm going to select this GM. And when I select this, it's going to be changing the temperature to resistance lookup, and that's going to be changing the reading to a different scale. So we're going to make sure that we select that. And we can see here we have the ability to select Fahrenheit or Celsius. I'll just go ahead and select Fahrenheit because that's going to be the operating scale that I'm going to be using here. We also can see this table input solution. We have the ability to do a custom ink file if we have a custom sensor that this is not going to fit the data for that sensor. We're able to go in and have more data points to hit. But generally speaking, you're going to be just going and selecting one of these sensors from our drop-down menu here. I suggest if you don't have any of these sensors on your drop-down, instead of going through the trouble of going in and creating a custom calibration scale, just get a GM air coolant or air temp sensor, it's going to make your life much, much easier. And if the sensor goes bad, you can source these in almost any auto parts store. So once I've selected my scale here, I'm going to click write to controller. We're going to see it's writing to controller now. We have to wait. Let's keep an eye here on our coolant temp gauge as it writes this. Now we can see that the write has completed, and we can see our coolant temperature is reading or registering here 64 degrees. Now my ambient temperature in my room right now is between 60 to 70 degrees. So we're seeing that it's reporting a ballpark value or logical value for the calibration scale. So that's going to be a checks and balances as we go through and select this particular scale here. Now next, we're going to go into our sensor table, jump down to air temp, and we want to go and select this and calibrate that. We can see right now our air temp is reading 52. It's reading a little bit colder than it should, but we're using a GM air temp sensor. So again, I'm going to go into my common sensor values. I'm going to jump here and select GM, and I'll select Fahrenheit as well. And we can see it's going to be changing that calibration scale. I'm going to click right to controller again. We're going to be patient and watching our manifold air temperature here. And now we can see it's wrote to the controller, and it's showing me now the updated value is 67 degrees Fahrenheit. And again, this is a logical value because my ambient temperature in my room is between 60 to 70 degrees. So this is going to be what you always want to do after you've done your calibration on a cold engine. These should read approximately the same. Within a few degrees will be sufficient. You might notice that the coolant sensor reads a little bit cooler because it's in water typically. And you're going to be finding that the water holds a little bit cooler temperature value, but they are ballpark approximate. What you shouldn't see is a major difference, 20, 30 degrees. That's going to be signifying something isn't right, and you have to go and check that. So again, this is going to be your checks and balances. You have your gauges up here. So we've done the write to controller. Let's close this. Now let's go in, and I've wired a wideband into my Megasquirt. Now I always suggest you have a wideband wired into the Megasquirt. It's going to be one of the very vital sensors that we need to do our fuel tuning with, and we're able to do the closed loop correction with our wideband that I'm going to be showing you in this training series. It's going to be an invaluable tool during your tuning process, and if you have a wideband already, there's no reason not to tie this in. So I've wired mine into my spare ADC input, and I have a AM 30-4100 gauge. So it has a standard 0 to 5 volt output on the output wire from the gauge, and it signifies at 0 volts we have 10 to 1 air fuel, and at 5 volts we have 20 to 1 air fuel. So if we jump in here into tools and we go to calibrate AFR table, we're going to be seeing we have the choice to select different sensor types or different calibration scales. If we click on this, we're going to be seeing we have a whole bunch of different ones we can choose from. So depending on what wideband we have, we can select it from the list. Now, in this case, if I don't see what I have here, if we jump up to the actual AEM ones here, I may not see my 30-4100. We are able to go in here and do custom linear wideband. And then in this case, I would define my 0.1, which is 0 volts, and my AFR associated with that, which would be 10 to 1 on this wideband. And then I'd see my 0.2 would be 5 volts, and then 20 to 1. Now, once I'm happy with that, I would do write to controller. We'd be patient here, and we're going to be noticing that my wideband input here is reading now what my wideband display is reading. So my wideband display is reading approximately 13.6 to 1, and now it's showing it here in the actual controller. And then if I go in and I go and put my sensor into the air, we're going to be seeing that it shows full lean or very lean values here, and that's because it's out of the exhaust stream and it's into the air right now, and it leans out. And this is going to be what you see when you lift your throttle. If you have your deceleration fuel cut on, you'll be seeing that it goes lean, but your wideband, as it shows full lean, when you're just key on, engine off, you're going to be seeing that it shows something like this in your display. So once we went in and calibrated our actual wideband and calibrated our coolant and air temp sensors, we're now ready to go back and unlock those calibrations. So just as we found under tools, we unlock them to access the calibration scales and to calibrate them. We're going to go ahead and lock them now. There's going to be no reason that we should have to go in and change these calibration scales at any point in time unless we change the sensor. If we change, let's say, our wideband to a different brand, or if we change to a different coolant or air temp sensor to a different style or brand, we're going to have to go and update the calibration scale. But for right now, we're not going to have to do that since we've calibrated them. We're going to click locked and then go into burn and burn that to the ECU, so it stores that permanently on the ECU and it knows what to expect for when they reads those sensors. So the last thing that we're going to have to calibrate here that is extremely important is going to be our map sensor. Now our map sensor is going to be displaying or reporting how much vacuum or how much pressure the engine is going to be under, and it's going to be imperative that it's calibrated correctly because our fuel and spark timing calculations will be coming from that sensor's reading under our operation. So we're going to be finding for turbocharged, it has to report positive manifold pressure. For naturally aspirated, or if even for turbocharged, you're going to have to report vacuum. So the amount of fuel and the amount of spark being delivered will be delivered in correspondence to our load on the engine coming from our map sensor. So first thing we're going to have to do here is right click onto an empty gauge. We're going to go here into sensor inputs, and we want to move up here to engine map. We want to pull up what the map sensor is reading. Now, this is key on engine off condition, so I haven't started my engine yet. And what I should see is that my map sensor is reading approximately 100 kPa or 0 psi. Now, this is important because the atmospheric pressure is going to be referenced at this particular point. So depending on our elevation, the map sensor's readings will change. So if at really high elevation, it won't read 100 kPa. It might be something like 85 or 90 kPa. And if we're at below sea level, or if we're at sea level and we have a very cold temperature condition, we have corrected altitude, that's going to be showing we that, and we have a negative density of air, dA, we're going to be seeing that we have a positive value here. So we're going to be showing maybe 102, 104 kPa, but in most situations you'll actually be below 100 kPa because you're going to be at some kind of elevation above sea level. So typically speaking, you should see about 96 to 98 kPa if you're checking this. Now it's important that it reads right at that point because that's going to be considered our 0 point. And then as we read into vacuum, it's going to be referencing that in our vacuum scale. And as we read into positive manifold pressure, it'll be reading above that. Now, if we start off with a map sensor that's not calibrated on the proper scale, as we can see right here, it's reporting 186 kPa. And this is impossible. We're not in positive manifold pressure with our engine not running and the ignition powered on and our box powered on. So we know right off the bat, looking at this, that our calibration scale is not correct. So in order to calibrate this, we're going to be jumping into tools, jumping into map barrow here, and we're going to do our calibration scale. So in this case, I have a GM 2-bar map sensor I have wired into my vehicle. So I'm going to go here and I'm going to go down into this common map sensors. This is a wizard list that's going to have a bunch of common sensors here. So we're going to see we have GM 1, 2, and 3 bar. We also see we have an AM 3.5 and 5 bar. We also see the ability to program a custom map sensor. So if you're running something like a 4-bar plug-and-play map sensor or something of that nature, you can see that you can select this custom. Now in this case, again, I have a GM 2-bar map sensor that's good up to 15 psi boost. So once I select it, it's going to be populating my 0 and 5 volt values here. And if I click burn and give it a second, we can see my map sensor now reads 96 to 97 kPa, which is going to be correct for my elevation right now. I'm right around 700 to 800 feet above sea level. So this is what I am reporting. So again, if you're at high elevation, you might be finding that you're as low as 80 to 85 kPa if you're at 8,000 feet of elevation. And if you're at sea level, you should see this reading approximately 100. And if for some reason you're at sea level and you have negative density of air being reported, if you're super, super cold air temperatures, you might be finding that the air is so good that it actually reports positive values here on our map sensor. So that's going to be something to keep in mind. But typically speaking, you should never see it go much higher than 105 kPa. That'll be something that I've never personally seen when I even was at perfect track conditions at negative 2400 dA or density of air at sea level. I saw the most about 104, 105 kPa. So now we've done our calibrations for our major sensors, and we're ready to move in now to looking at some of the basic configurations to set up our cam and crank sensors and to set up our fuel requirements and to give the Megasquirt all of the next necessary details in order so it understands what kind of engine we're trying to control and what kind of fuel system we have installed onto our vehicle. So now that we've done our major sensor calibrations, we're ready to move into defining some other very important details associated with our engine that we're trying to control. So the engine displacement, the number of cylinders, what size injectors we have installed, so that the Megasquirt's going to understand the next things that we need to look for in our fuel calculations and to reference for our spark timing. So that wraps it up for this video. Hopefully it was very useful. You're going to be able to apply it to your vehicle to get it set up and then ready to go into our next video here. Okay, so that wraps up Megasquirt training part 4. In the next video, we're going to be taking a look at our general settings in our Tuner Studio software. We're going to have a lot to learn, so I'll see you in the next video.